Finding the remainder using a long division method. So when you are using a long division method, the most important thing that you need to know is that you first divide. After dividing, you put your quotient up there and then you multiply by the term that is on your left. But when you are multiplying, you use both. You start by this one and you come to 3 and you write your product just down here and then you subtract. If x is still there, you continue dividing up until your polynomial does not contain x. As you can see, this is your remainder. Right, let's move to what we call the factor theorem. The factor theorem. Right, factor theorem is a bit different from the remainder theorem, because factor theorem, it states that if a polynomial f of x is divided by ax minus b and the remainder is 0, then ax minus b will be a factor if the remainder is 0. If a polynomial f of x is divided, the value f of x is divided by ax minus b and the remainder is 0. Is 0. Then ax minus b will be a factor. So if a polynomial f of x is divided by ax minus b and the remainder is 0, then ax minus b will be our factor. Let's try to make an example. I will be the example of course. It's born to say for the class.
It's x cubed
X cubed
plus 2x squared.
plus 2x squared.
It's plus x squared, I mean.
Plus x squared, yes.
Yes, plus x squared.
It's x cubed plus
X squared
x squared
minus x minus 1
minus x minus 1.
equals to 0.
This is equal to
0.
0. So let us use f of x so that we are going to meet the factor theorem. Let's say it's f of x. So for you to find the factor here, or to factorize this, you need to firstly find the first factor. To find the first factor, you use the integers starting from -6. Make sure that those integers are the factors of 6, excluding 0. It's minus 3, minus 2, minus 1, 1, 2, 3, up to 6. So use that set of numbers to find the factor here. So as you are substituting by any of those numbers here, we call that a factor theorem, because we want to check if when we are substituting by any of those numbers, we are going to obtain 0. So can you quickly find me the factor using those numbers?
-1.
It's -1. So let's put -1. We want to check if we are going to get 0. Right, find the answer. This is -1 plus 1 plus 1 minus 1. 1 plus 1 minus 2, that would be 0. So since our remainder is 0, that will mean this is our factor. Remember, this is -1. We are talking about ax minus b, which means here we've got f at x, which is equal to x cubed plus x squared minus x minus 1 divided by ax minus b. Our x there, it's -1, which means it's x plus 1. This is divided by x plus 1. So since we are saying -1 in place of x, that means you have solved for x there. It's x plus 1 equals 0. Therefore, x is equal to -1. So that's how to use what we call the factor theorem. Let's try to use the long division to check if the remainder will be 0 again. We are going to use same factor, which is x plus 1. X plus 1 is a factor. X plus 1 is a factor. X plus 1, and then our polynomial, it's x cubed plus x squared minus x minus 1. Right, divisor, polynomial. We start again, we are dividing. X cubed, this is x cubed, this is x cubed. 1 plus 1 plus 1, that is x cubed. So we are to divide here. We are dividing x cubed divided by x. So we are left with x squared. X times x squared, that will be x cubed. And then we multiply by 1 again. 1 times that, it's plus x squared. The next step, we subtract. X squared minus x squared is 0, I mean x cubed, and then x squared minus x squared again, it's 0. We have to drop down that, it's minus x minus 1. Remember, we've got x here, therefore we continue dividing up until there is no x. Negative x divided by x. Negative x divided by x. That would be -1. And then the next step we multiply. X times negative x. That would be negative x. 1 times -1. That is -1. And then we subtract. Minus x minus -x, that would be 0. Minus 1 minus -1, that would be 0. There is no x, there is no remainder, our remainder is 0. That means x plus 1 is a factor. X plus 1 is a factor, because if you divide here, you find out that the remainder is 0. So that's how we use what we call the factor theorem. But then, remember, this is a cubic polynomial. There are some other ways of factorizing a cubic polynomial. We are going to look on a few of them. Right, you factorize by taking out a common factor. Let's say ways of factorizing. Hey, factorizing. This is right. Number one, we factorize by taking out a common factor. Factorize, is it S or Z?
It can be S or Z.
Either of the two. Oh, this is this. Okay. Factorize by taking out a common factor. And then number two, factorize using factor theorem. Factor theorem. By grouping synthetic, and then by inspection. By inspection. Right. Can you find me any problem there such that we'll be able to factorize by taking out the common factor?
Can be negative x cubed
Negative x cubed
plus 4x squared
plus 4x squared
minus 4x
minus
4x
4x
equals to 0.
equals 0, right? We are to factorize here. So obvious, since each of these terms has got x, that means x is our common factor. But then let's firstly divide by negative 1. You are allowed to divide by negative 1 because there is 0 there. If there was a letter or f at x or g at x, you can't divide, you just factorize. So this will be x cubed minus 4x squared minus 4x. This is equal to 0. And then we take out our common factor, which is x. This will be x squared minus 4x plus 4. This is equal to 0. We have taken out a common factor. It's x cubed minus 4x squared plus 4x equals 0. So this is, you are taking out x because each of these terms has got x. Therefore, it's x into x minus 4x. You took out x, remember. So plus 4. That's the reason why we've got x squared minus 4x plus 4. So let's factorize this completely. It's x into x minus 2 into x minus 2 equals 0. So you were just factorizing. We are not solving, we are factorizing. So you took out the common factor, which is x, and then you factorize completely. That's how to factorize, by taking out the common factor. Let's see on how to factorize. There are some few cases where you will be factorizing by grouping, but then we are going to look at it. Let's go to synthetic method. Can you give any expression there so that we can use it to explain synthetic method?
X cubed
X cubed
plus 4x squared
plus 4x squared
plus x minus 6.
plus x minus 6. Can you quickly find the first factor? So, as I said, we use factor theorem to find the first factor, using the factors of 6 starting from the negative numbers to the positive numbers. But those must be the factors of 6. So, we need to have the table if you are to use synthetic method. We need a table. And then we write the coefficients in each of these columns. The coefficient here is 1, here it's 4, here it's 1, and then the constant, which is minus 6. Right, you've written all the coefficients there, and then you write your factor here. Can you give me the factor? Negative 1. So you write negative 1 here. It's a factor, and then the coefficients of the given polynomial or of the given equation. Right, the first thing you do, you put 0 here. And then you add 1 plus 0, it's 1. The next step, you multiply. Negative 1 times 1, that would be negative 1. Remember, we said 1 plus 0. Again, you do the same here, you add 4 plus negative 1, that would be 3. And then you multiply. You add, you multiply. You add, you multiply. Negative 1 times positive 3. That's minus 3. We are multiplying, so a positive times negative would give us a negative number. 1 plus negative 3, that will be minus 2. The next step, we will have to multiply. Are you sure that this is, or this was our factor?
Yeah.
Can you check to make sure that was our factor? It has to give us 0. Put it there and check if it gives us 0.
We have got another factor that will be x plus 2.
X plus 2, it can be a factor.
X plus 2.
Yeah.
So, because when you look here, it seems like it won't give us 0, the remainder. Our remainder has to be 0. So, let's put, you are saying it's
Minus 2.
minus 2. It's minus 2. So, let's start again here. I will show you why we have to start again. Remember, a factor must give us a remainder which is 0 at the end. So, we add, this is 1. Negative 2 times that, it's minus 2. And then we add, this will give us 2. And this is minus 4. This will be minus 3. Negative times negative. And then 2 times 3, that will be 6. Minus 6 plus 6, that will be 0. As you can see, this is our remainder. Our remainder is 0. That means negative 2 is our factor. That's the reason why we had to start again, so that we are going to get 0 there. And then from there, Remember our factor there, it's x plus 2, that minus 2. And then the next bracket, it's where you are going to put, this is the coefficient of the second bracket. It's x squared, x. That's your second bracket. You need to have ax minus b, ax squared plus bx plus c for the second bracket. So it's a linear times a quadratic. Same thing here, you just put x squared, ax squared plus bx plus c. So this will be our quadratic, which is x squared plus 2x minus 3 equals 0. Let's factorize the second bracket. It's x plus 2 into x plus 3 into x minus 1. This is equal to 0, which means we were not supposed to put minus 1 there, we were supposed to put positive 1 in the place of that. But then that's how to factorize using what we call a synthetic method. It's a synthetic method. Synthetic method. Right now we are going to move on, use what we call factorizing by inspection. By inspection. Can you give me the equation? Let's use the same equation. X cubed plus 4x squared plus x minus 6 is equal to 0. And then we said our factor is x plus 3, right? And then let's find our quadratic, which is our second bracket. So if you are using this one, inspection, you need to find the factors of this. So if you say x, which number can you multiply, or which number can you multiply by x to give us x squared? That would be x squared, to find x cubed, right? And then to find 6 from 3, that is 3 times, we need to find negative, isn't it? So it's 3 times negative 2, right? 3 times x squared, that is 3x squared. So from 3x squared to 4x squared, we add, isn't it? We need to add x squared, right? But then the only missing term here is the middle term of the quadratic. So we say plus x, so that we are going to have x times x to give us x squared plus 3x to find that 4x. So we simplify the first term by saying x times which number. That will give us that cube up there. So it's x times x squared. Also, to find the last term, it's 3 times negative 2. And then for the middle term, it's 3 times x squared, which is our 3x squared. So to go to 4x squared, we are only missing x squared. So we put x as it is. You do not put squared because of got squared already there. So that it will be x times x. That's how to factorize by inspection. Let us complete this. It's x plus 3x, x plus 2, x minus 1. This is equal to 0. Same as here. But when you look at the second bracket, since we've started by x plus 3 here, it's no longer the same as that one. We've got x squared plus x minus 2, whereas here we had x squared plus 2x minus 3. Right, that was division by or factorizing by inspection. So for now, let's stop there.